Doctor.
Hi, how are you today?
Fine.
So, I guess ready to learn new things for today?
Yes.
So, today we are going to learn about smart material.
Wow, smart material.
Yeah.
Wani, you have any idea of what is smart material?
No, I didn't know.
So, do you guys ever heard about this before?
No.
Okay. Smart material is the biggest family of all. So, one of the example is shape memory alloy. So, do you guys know what is shape memory alloy?
No, we have no idea.
Okay, you can learn from today. So, shape memory alloy is actually an alloy who is defined, which can use a thermoelastic martensite. So, martensite is a phase where crystallographically reversible. So guys, let us continue with the details review about this shape memory alloy. So firstly, it is the metal that remembers the original shape, which the alloy remembers its original shape, and when deformed, it returns to its pre-deformed shape when heated. So it is lightweight alloy. So secondly is shape memory alloy are useful for such things which are materials that change shape, stiffness, position, and its natural frequency. So for example, like for nickel titanium, which is we call also nitinol, is the most useful material in this industry in the world. So for example, like for braces, eyeglass frame, paperclip, and also in robotics, they use this nickel titanium, which is nitinol. So for this topic, I want to give an assignment for you guys. So Alwani, I want you to find a video about this shape memory alloy. Can you?
Alright, okay Doctor, I will find the video for the smart material.
Okay, thank you.
Assalamualaikum and a very good morning to Doctor and to all my classmates. So today, as Doctor have given me an assignment about the what is smart material alloy, so I will show to all of you about the video about the demonstration of nitinol, which is metallic muscle with shape memory. So this is the video.
Hi, hello everyone. Okay, today I would like to show to all of you a demonstration about one unusual object, which is paperclip. Paperclip is made by an unusual material, which is nitinol. Nitinol is an alloy of nickel and titanium, which the proportion of nickel is 55%, while 45% for the titanium. Nitinol has a unique property. The property of this alloy, also known as shape memory. So let's conduct a demonstration of this nitinol. Take a paperclip and deform it. After that, take a spring, also deform it. So the activation temperature of nitinol is about 40 degrees Celsius. The stove is heated, and then put the deformed paperclip on its surface. When it's heated, it back to its original shape. So nitinol is more 10 times elastic than other metals. So this is the example of a nitinol in hot water. When the deformed paperclip and spring put in the hot water, it back to its original shape. So now let's see other demonstrations. Attach the spring on the tripod and hang the basket. So the spring will stretch or deform to it and deform. Put heated on it and it's back to its original shape. So it is a really reliable alloy. It can be used on our daily lives. Nitinol used in many fields such as medicine on our bone. So that's all. Bye.
Hey sir,
Oh,
do you know
yes.
what's this smart memory alloy? Yeah, you
do you know what is smart memory alloy?
Oh no, I
SMA?
have no idea.
Okay, let me introduce you
Okay.
this material and the advantages and the disadvantages. Okay, smart material alloy, we call SMA, is a lightweighted material used in the industry and is biocompatible, which means does not contain toxic and it will not harm to the environment and human being. It can be used in diverse of yield in application. Yep, for example, military, medical, safety, and robotic application. It has good mechanical properties, which is strong, and it can resist corrosion, heat, and high pressure. It has shape memory properties and super elasticity. Okay, you can see it in the brochure, which are unique characteristic and totally new in the medical field. It can be employed in the artificial joint and marrow pins in the bone plates. Besides that, it can able to make self-locking, self-expanding, and self-compressing thermally activated implants.
You mean the advantage is this one?
Yep. This one.
Okay.
It's about the smart material alloys, SMA. It has the potential to be a clinical success in several applications in the future. So it is very helpful to the medical field in the future. It will be more usable and better compared to the other materials.
Okay, so these are the advantage, right?
Yeah, advantage.
But I think that really materials also have
Everything
disadvantage.
has pros and cons, right?
Okay, so you can explain to me about the disadvantage, is it?
Yep, okay. Disadvantages of SMA, they are relatively very expensive to manufacture and machine compared to other materials such as steel and aluminium. Okay. They also have poor fatigue properties, which means they can easily break when they fall in the floor. And under the same loading conditions such as twisting, bending, and compressing, a steel can survive more than 100 times than a smart memory alloy element. SMA needs proper handling and care since it is very expensive and it's hard to, it can be easily broken. This is the disadvantage, but we can conclude that the disadvantages is more than advantages. So it is still advisable can use this material in the industry.
If I'm interested, I definitely come to your shop.
You can contact my number then.
Okay, sure.
Thank you.
I'll WhatsApp you. Thank you.
Okay, thank you.
Hello everyone, my name is Petrina Patrice Fittipaldi. I'm currently majoring in spacecraft engineering. So, as a team, we are now working on recent scientific work related to SMA, which is smart metal alloy. From the early stages, as you can see, thermal engines. So, designers as well as engineers, what are they doing now is they are trying to convert, they are developing ways to convert thermal energy into mechanical work via crystallographic phase change of SMA, which is now going on for decades in our real life. Besides that, as you can see, these engineers and also designers, they are utilizing both shape memory as well as pseudo-elastic effects on SMA. These implementations can be done in few applications such as spacecraft, aircraft, and also rotorcraft applications. So, I have few slides here which I can share with you some information on aircraft, spacecraft, and rotorcraft. Here you go.
As told, I'll discuss a bit on the aerospace and spacecraft applications. Smart Wing program was intended to develop and demonstrate the use of active materials, including SMAs to optimize performance of lifting bodies. The project was split into two phases, with the first being the most SMA intensive. Here, SMA wire tendons were used to actuate hingeless ailerons, while an SMA torque tube was used to initiate spanwise wing twisting of a scaled down. The figure here shows total and cutaway view of a SMA torque tube as installed in the model wing during phase 1 of the Smart Wing project. Entering to spacecraft application. Space applications are those which seek to address the unique problems of release, actuation, and vibration meditation during either the launch of spacecraft or its subsequent operation in a microgravity and zero atmosphere environment. Perhaps the most prolific use of shape memory alloy in space is in solving the problem of low shock release. Much smaller devices such as SMA elements for actuation has also been proposed, such as micro sapnut. The active component is deformed and detwined before installation. In orbit, the element is then heated, shape is recovered, and release occurs. Repeated use mechanisms such as rotary latch has also been introduced. The figure below shows rotary latch as designed and tested at the Applied Physics Laboratory. I hope you have gained something from the information I have shared. Thank you.
Okay, Shawin.
Hello all. Okay, so today I will explain to you about the in-depth analysis of the properties of smart memory alloy.
Audio Jungle. 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 Audio Jungle.